second video for chapter 4 for geometry. We're in 412 is our lesson. And last video we learned that there's a couple of relationships we can kind of focus on between slope and angles. So the big thing we were looking at is we could draw a line on a graph. We could pick 2 points on that line, so any 2 points you feel like making up right now. And we could connect those points by measuring the slope with a triangle. So we could take the points and make this 90-degree slope triangle. And if we can measure how long the triangle is, we call it delta y and delta x. We can make a ratio out of these and say that slope of this triangle equals delta y over delta x. Rise over run. Something we learned in algebra over a year ago. So we've known this for a while. Yesterday, or in the last video, we were looking at angles. So we were saying, like, okay, now that I know the slope, I want to know more about this triangle. So we started looking at, well, what's the measurement of this little angle right here? And we called it theta, a Greek letter that stands for an unknown angle. So we said, well, this is theta, and we were just kind of curious about, well, how big is theta? How big is the angle? And we found out that the angle really depends on what the slope is. So we call that theta, we call that the slope angle. And the slope angle in this picture equals theta. So just to kind of recap, we only focused on a couple of angles and a couple of slopes yesterday. And so today what you're going to be doing is you're going to be using a resource page. Hopefully you got this from class, and it looks like this. It's a table of angles, slope triangles, and ratios, and it's a table that if we could fill it all out would be a really good resource for us to kind of go back and look at. So inside this table is a really generic, just like we drew, a generic triangle with a theta angle. Yesterday the one that we studied 11 degrees. We found out that if we have a line with a slope of 1/5, so delta y and delta x is 1 over 5, then the angle measured 11 degrees when we used our protractor. We also looked at a couple of other angles yesterday. We did the 22-degree angle, if you remember. So let's draw a triangle for the 22-degree angle. Remember, all of these are right triangles. We found out that if this angle is 22 degrees, you have to write pretty small inside of there, that the measurements of the sides are 2 and 5. So we found out that delta y over delta x equals 2/5. As a decimal, 2 divided by 5, if you use a calculator, is 0.4. So for that ratio. We also discovered 45-degree angles. We found out that 45 degrees, if I draw a triangle with a measurement of 45 degrees in this corner, that the side lengths were the same. It was 1 and 1. So delta y over delta x was equal to 1 over 1, which 1 divided by 1 is just 1. So it has a ratio of 1. And really, I think these are the only ones we really looked at. We looked at 11 degrees, 22 degrees, and 45 degrees. And just knowing those three, I haven't filled in the rest of the table yet, but I can still solve a lot of problems. So I want to show you a couple of examples of what you'll be able to do. We're going to make up a problem here. So let's say, for our example, for this video, that I make up a triangle, and I tell you that this triangle measures 90 in the corner and 45 degrees here. And I tell you that I happen to know how long the triangle is on the base. It's 8 units long, and I want to know what's y. What's the side length? Well, because I know it's a 45-degree angle, I can go and look at that trig table, and let's see, let's put it back up here. I can look at this 45-degree relationship and say, well, it's always 1 over 1. So based on that, this is how I'm going to solve this problem. I'm going to say, okay, for all 45-degree angled slope triangles, I know that the relationship is 1 over 1. So in this case, I have y and 8. So 1 over 1 is going to have to equal y over 8. And I'm going to solve for y. I already kind of know this one in my head. It's going to be 8 over 8. If you need to solve it by hand, you would cross multiply. You do 8 times 1 is 8. 1 times y is y. So my answer is y equals 8. It's a pretty straightforward, easy example. So let's do another one that's at least a little more difficult than that. So I'm going to flip the page here. How about this? What do you think we would do for this triangle? I have a 90-degree right triangle. And in the corner, it measures 11 degrees. My theta is 11 degrees. And I happen to know that the bottom here is an unknown measurement of x, but over here, it's 10. So solve for x. Well, look at your trig table. What do we know about 11 degrees? 11 degrees. 11-degree angles in a triangle. Well, if I look at my table, I happen to know that the ratio for these right triangles with 11 degrees is 1/5, 1 over 5. So I'm going to build off of that. I'm going to say, okay, an 11-degree triangle has a 1/5 ratio. And if it's 1/5, then for this one, it's going to be 10 over x. So 10 over x. So I'm going to solve this proportion. I'm going to cross multiply. X times 1 is x. 5 times 10 is 50. So I'm going to guess that x is going to have to equal 50 units. So why don't you try a problem? I'm going to put one up here for you. Kind of freeze the video for a moment. Pause the video and just try it and see if you get in the hang of this a little bit. So how about this? I'm going to give you a triangle, another right triangle, with a measurement of 22 degrees in the corner. And I'm going to tell you that this side on the bottom measures 20 units, and this is A. Solve for A. Use your trig table and solve for A. Okay, so hopefully this is what you did. You looked at the table and you noticed that 22 degrees in the table has a relationship of 2/5. So you write 2 over 5. Because of that relationship, I know that it's got to be proportional, that A and 20 have to make the same fraction, A over 20. So I'm going to solve by cross multiplying, doing a little bit of algebra. 20 times 2 is 40. 5 times A is 5A. So I get 40 equals 5A. So I'm going to solve 40 equals 5A by dividing by 5. And I'm going to get 40 divided by 5, which is 8. So the answer is A must be 8 units long. And I can put that up here on my triangle if I want, equals 8. So you're going to be doing kind of a lot of these in class. I'm not going to do many of the problems out of the book because I want you to save those and work on them in class. But I do want you to kind of see how the table can be kind of handy to help you set up these problems. It's pretty limited right now. We only know a couple of these triangles, the 11 degrees and the 22 degrees and the 45. We got to work at finding all the rest of these and kind of completing this table. So we're going to be doing that over the course of the next couple of days. So hopefully this helps. Do the problems in class and work with me in class, work with your teacher to kind of figure out how to do the rest of these. All right, thanks.